In this lesson, we're going to look at how to use our calculator to find the correlation coefficient and how to generate a linear regression. Now, let's talk about what a linear regression is, and I'm sorry I should have made a space for us to define this. So basically, what we're looking at is a linear regression is an equation. It's an equation of our trend line. If we have a scatter plot, we're using our calculators and to make a prediction of what the trend line should be and what the equation of that trend line is. And the whole purpose of generating this equation is to use it to make predictions. If we have an equation, then we can plug in numbers to our equation to make predictions about the data. Now, let's talk about what the correlation coefficient is. This is a statistical measure, which if you go on and take statistics later on, you'll learn more about this. This is a statistical measurement that tells us how closely the equation, the linear regression equation, models the data in a scatter plot. So is the trend line or the equation a really good fit? Does it model most of the data? Or is it a really bad trend line and it doesn't model it? We use the variable r to model a linear regression. We'll see later that we use r squared for quadratic regressions. The nearer r is to 1 or negative 1, the better the line of best fit or trend line represents the data. And it's really important because we have strong and weak correlations. And the magic number is negative 0.8 or positive 0.8. So if r is between negative 0.8 and negative 1, then it's going to be a strong negative relationship. If it's between 0 and negative 0.8, it's going to be a weak negative. It's perfect if r is exactly negative 1. That's saying it's 100% accurate, whereas 0.8 is saying 80% accurate. And then we can have the positive, and again, 0.8 is the cutoff. 0.8 to 1 or 80% to 100% is a strong positive. And if it's between 0 and 0.8 or 0 and 80%, that would be a weak positive. Okay? Now, I have the steps for you over here in this little box, so hopefully that will help. I'm also going to walk you through it. So we're going to take this first set of data that I have here on our table, and we're going to write the line of best fit or the linear regression equation. We're going to write the correlation coefficient, and then we're going to decide what we know about the correlation coefficient. Okay, so the first thing we have to do is input our data from the table into lists. So what you're going to do to input lists, is you're going to go to stat. Now I know it says list above it, but we don't want to go to list because we actually have to input it. So press the stat button, and then we're going to choose edit. So you can choose 1 or choose enter. And now we're in L1. So this is going to be where we put our X values. And notice it's basically 1 through 9. So I'm just 1, enter, 2, enter, 3, 4, 5, 6, 7, 8, 9. Make sure you're hitting enter after each number. Okay, if you need a minute to do that, pause the video and then start back up. Now I'm going to arrow to the right, and I'm going to input all the Y values into L2. So we've got -7. Make sure you're using the negative key. That's super important. You've got to use this key right here. Okay, so we've got -7, -4, 0, 0, 1, 4, 7, 9. Okay, so make sure that you're entering all of the numbers. Make sure that your lists match up, that you have the same amount of numbers in each column. If you don't, you're going to get an error message. Okay, the next thing is, let's go back to our home screen, so second mode. The next thing is, if we're going to find the correlation coefficient, we have to make sure that our diagnostics are turned on. So we're going to press second and 0, or second catalog. So second 0, and you should have a list that looks like this, and we're going to scroll down to where it says diagnostics on. Okay, diagnostics on, and we're going to hit enter, and then enter one more time so that it says done. Now you don't have to do this every time, but if your diagnostics is not turned on, your calculator will not give you the correlation coefficient. Okay? And so now we're ready for our calculator to tell us what the linear regression or line of best fit is. So let's press stat again. Now you're going to arrow over and choose calc. You're going to choose number 4 for linear regression. And then you're going to hit enter. And there is our data. Okay, so let's write down what we've got here. So notice that the A is our slope. So 1.8 is our slope. The B is -8, our y-intercept. So our line of best fit, our linear regression equation, is y equals 1.8x minus 8. That is our regression equation. That is our line of best fit. Now, for the correlation coefficient, notice there's 2 here, but we said that R is what represents our correlation coefficient. So our correlation coefficient, I'm just going to write 0.976. That's enough. Okay, now let's interpret it. What does the correlation coefficient tell us about the data and line of best fit? Well, if this is our correlation coefficient, it's positive. So is that a weak positive or a strong positive? Okay, hopefully you're saying strong positive. So we would say that this is a strong positive relationship, and the equation models the data well. And so now what we could do is, and this really isn't talking about anything, but we could take this equation now, and let's say we could predict what is the y value when x is 20. And so I could take 20 and I could plug it in for x, and I could predict what the y value would be. Okay? And so that's all there is to correlation coefficient. So now what I want you to do is work through the rest of the problems and answering the questions and see if you can do all of that on your own.